We're going over 4.4 properties of definite integrals in this video. I just divided into two parts, really. The first part, we're going to look at the area of a region bounded by two graphs. Looks like example 3, I will have 3 graphs. But the daily problem, instead of giving me, because you know how I've been giving you very similar daily problems at the end of each lesson, but I just included the daily problem for 4.4 as number 8 on your exam. So number eight on your exam is, I know you guys are studying this. Where are you, Google Doc? This Google Doc this week. Let's see if anybody's in it right now. No visitors right now. Oh, you know what? There are 4 people in here. Hello. Okay, but anyways, what I'm about to go over, and really just the first part, 4.4 properties of definite integral. I'm just going to ask you to find the region bounded by these 2 equations. So what I'm about to go over in the next 20 minutes, if you watch it, you should be able to try number 8. That's like a daily problem. And if you want me to also go over number 8 on this document, you just let me know. I'll just keep it very similar, a quadratic and a linear on your actual exam too, okay? Just kind of want you to try one. But instead of a daily problem and another exam problem, I'm just going to give you one so that I can assess it on your exam 3, okay? All right, let me go back to 4.4 notes right here. So when you find the area bounded by 2 graphs, here's the idea. Say that you have a graph, and say that you have a graph that goes like this, a linear function, and you have another graph that goes like this, a parabola. And if you want to find the area that is bounded by these 2 graphs, that blue area that I just highlighted, you see what we can do is we can find the area under the curve of that black line, and then we can subtract the area that's under the, you know what, let me draw a better one. Yeah, draw a better one. Say that you have a line that looks like this. And this is like, I think your exam problem is going to be like this. And then I will have a quadratic going like this, okay? So if I ask you to find an area that is enclosed by these 2 graphs, that piece is what we want. What we can do is we can find the area under the line, under the straight line, which will be this much, right? And then we can subtract the area that is under the parabola, right? So that's what we're going to do. We're going to find out who is on top, which graph is on top. We're going to subtract these 2 functions and just integrate it from an endpoint to an endpoint. And the endpoints are going to be just their intersection. So that's the idea for finding the area of a region bounded by 2 graphs. So I'll start with example 1 and 2 and 3 in this video, and then I will stop. Because the second part, average value of a continuous function, I didn't really put this one on your exam, but you will see couple on just like example 4, 5, and 6 on your 4.4 homework that is due this Sunday. So I'm going to come back and go over it. But if you're just getting ready for your exam 3 tomorrow, example 1 to 3 will be enough, okay? And all right, let me get started. So I copied a theorem down here for you. Let f and g be continuous functions with f is greater than g over this interval a to b. Now, you're going to have to figure out who is bigger and who is higher, or who has, you know, so that we can subtract. Because we want to do this blue graph minus, the blue graph minus this red graph. So figure out which function has higher values, or which is bigger over this closed interval. Then we can find the area of the region between 2 curves from A to B by just simply finding the integral, the definite integral. You will subtract the big function minus the smaller function g of x, and then you will just integrate it from A to B. Let's actually do one together, okay? So A, example 1, find the area bounded by the graph of a given equation. Now, it really helps to have a graph though. So here's what I'm going to do. I'm going to use my graphing calculator to graph this, and then just to have a visual, you know, it will be helpful to have a nice picture to see what kind of region it is. Is it like a square looking graph? So what I'm going to do is I'm going to graph y equals 3. And if you want to include a nice graph on your exam, I would love that too. That will look very good instead of you just doing calculus. Y equals, what was that one? 4th root, right? Oh dear, how do I enter 4th root? Hold on. Because I see a square root here. Maybe I go to functions. Nth root. 4th root of x, right? And then the third equation was x equals, that's going to be a vertical line, x equals 0. So guys, I got a graph right here. I graphed 3 lines. They graphed it in blue, red, and green for me. The green line is actually the y-axis, right? X equals 0 is a vertical line sitting on top of that y-axis. So I see that they're kind of going far ahead. Now look, that's the left bound. The green line is the left bound. And then it's keep going to the right, right? So I gotta see where it is stopping. So what I'm gonna do is I'm gonna play with this zoom a little bit. I'll make the zoom for the y-axis a little bit smaller. So let me make the y-axis zoom to go from like -1 to like 5 for the y-axis. But then I want to see more on the x-axis. I want to see from like -1 to I think maybe 50 for right now. Let's see. Oh, did I mess up? Oh, I think I messed up. Totally messed up. Our y-axis, -1 to 5. And then x-axis, I'm going to make it go from like -1 to 100 for right now. Oh, no, I'm not entering 100. I was entering 1 point. Okay, that looks great. Now take a look. I just played with the zoom a little bit and I see a clear graph. Okay, I'm going to take a screenshot of this and then I will post this on my picture, on my notes, okay, so that you guys can see it. Oh my gosh, no, don't draw it. So do you always need to have a picture? Not really, but it will be helpful to have one. Just going to go ahead and save it for right now. Save to photos. And then I will go back to my notes. And then I will paste this picture over here. Photo library. What are the pictures that I have? Recently added. That's my son. Ah, here it is. Okay, so what I did was I kind of used Desmo's calculator app to graph these 3 equations, and I can clearly see what region we are talking about. So let me go ahead and use my highlighter to color that region that we're trying to find the area of. Okay, so this is that green region that we're trying to find the area of. So what we are going to do is we're going to use calculus to find the area. Give me 1 second. All right. Now, let me label these equations, okay? This horizontal line is y equals 3, right? And this vertical line is x equals 0. And this curve is our y equals cube root of 4, right? So if I want to find the area, what I'm going to do is I'm going to have to do subtraction, right? So which function is higher? Which function is greater? Notice this is a greater function, right? Greater. And this is smaller. Why do I say that? Because this line, what I mean by greater, is above, right? This function is above. And then the function that I said smaller, this function is the below, right? So that's what I mean by that. So when you can see which one is greater, which one is smaller, you will subtract them. So you will do y, well, this function, 3 minus 4th root of x, and that is going to be that's the function that you're going to integrate from what to what though? What are the endpoints? On the left endpoints, or left bound is going to be 0, right? From 0 to, and what's this point? Now, here's the great news though, guys. Because I graphed it on a Desmos calculator, I can see the endpoint is what? It's 80. Now, say that you don't really graph it though. If you don't graph it, will we be able to find where they intersect? Absolutely, right? So what we can do is this. They intersect when they have the same function value, right? When they have the same y value. So this is what you can do to find 80 algebraically. Set that function 3, that's the first function, right? Equal to 4th root of x, okay? So in order for us to solve for it, raise both sides to 4th power. And if I raise 3 to the 4th power, that's raising what? That's 9 times 9. That's going to be 81. Oh, I'm so glad I did that. Because was it really 80? No, it was 81. So I guess my graph, it looked like 80 to me because it was 81. But I'm going to go ahead and change my upper bound because I just found out algebraically. And because algebraically, it should be the way to go, really. It looked like 80 to me on the graph, but if I solve it, set these two functions equal to each other, then I got they intersect at this point 81. That's how I figure out the bounds. And then all I need to do now is just evaluate this definite integral. So finding the area problems, I think the difficult part is, you want to kind of have a good sketch to see which function is greater in that closed interval so that you can subtract in right order. If you accidentally subtract in the wrong order, 4th root of x minus 3, then your answer won't really be right? And then also finding the endpoints, the left bound and the right bound. Now, if you set that up, then we're ready to get started. Let me go ahead and go integrate this together. So the 3 will come down as what? 3x. And before I do that, let me go ahead and rewrite this. As you notice that this is 3 minus x to the what power? 1/4 power. So I just rewrote it in exponential form with the rational exponent so that I can use the power rule. What's the antiderivative? That's going to be 3x minus x to the 5/4 power divided by 5/4. So let's just multiply by the reciprocal of 4/5. This is using the power rule that we talked about in 4.1, right? All right. Was it 4.1? No, 4.3. 4.1, can't remember. But we did this. Now, what are the bounds? Remember this intermediate notation that we write? And we put the antiderivative in the square bracket. And we put the upper bound and lower bound. And now, in order for us to evaluate this, we're going to plug in 81. 3 times 81 minus 4/5 times 81 raised to the 5/4 power. And then what do? You subtract, right? You subtract the value that you will get when you plug in the lower bound, 0. And that part will just come out to be what I'm writing in red. This will just be 0, right? That just comes out to be 0. So our final answer, the area that I shaded in green, will just be that. Now get your calculator and type this in for me and see if you and I get the same thing, okay? So that's 3 times 81 minus 4 times 81 raised to the 5/4 power. And it comes out to be, hold on, I typed something wrong. It's 48.6, but I'm going to go ahead and just write this as a fraction. This is going to be 243 divided by 5. So that's how you would find the area under the curve. And I'm not sure if your my math lab homework will ask you to write this in decimal or a fraction, but I guess I'll write both. This is also 48.6. And if they even want a mixed number, you can say 48 and 3/5. Okay, so just because when you're doing your homework and on the exam, it's okay. all three answers are looking great to me. But when you're entering these answers on your homework problem, just make sure that you follow their direction. If they want decimal, give them decimal. If they want mixed number, write them mixed number. Okay? Alrighty. Now let's try another one. Two more. This finding area of a region bounded by two graphs. So example 2 and example 3. And I'll do the same thing. I'm going to graph them. Find the area of the region bounded by the graphs of the given equation. So I got two equations, and this is like what you will see on your exam this week, tomorrow. You will get a quadratic and a linear. I'll keep it as quadratic and linear tomorrow. Okay. So let's go to. I'm going to Desmos because I want to see the picture. The first equation was y equals 5 minus x squared. Oh, it's a quadratic right there, going upside down. And the second one is y equals 5 minus 5x. All right, they use purple and black. Okay, so that's the area they found for me. Now, I better see where they're intersecting. Looks like they're intersecting right here at 0, 5. We need the x values. And then they also intersect down here. And that point is 5, negative 20. Now, graphing is such a powerful method because I get to see where they intersect. And I actually get to see who is higher. Which function is greater in this closed interval? Which one is above? The purple one. The quadratic is greater here. So when we set up our integrand, we're going to do quadratic minus the linear case because the purple line is above the black line in that closed interval. Now, before I take a screenshot of this, I think I'm going to go ahead and change the zoom or the window a little bit so that I can have it kind of spread out. So it looks like y goes from 0 to 5-ish. So let me go ahead and, x goes from 0 to 5. So let me change the x-axis to like -1 to 6. And then I'll change the y-axis to like, the highest is 5. The lowest looks like -20. I'll change the y-axis to -21 and 6. Looking amazing. Okay, and then I will take a screenshot of this and then I will post it on my, I will put it on my note. But you guys see how I'm getting these pictures, right? I'm just using a graphing calculator. Save to photos. Why am I doing it? I mean, can somebody do this without graphing it? Of course, yeah. But I'm a visual person. I gotta see what I'm finding. What I'm finding here is the area, looks like a pizza crust, of this. Highlight this. Hopefully in Calc 2, you guys will rotate this around the x-axis or y-axis, create some solids and find the volume. But in Calc 1, we're just going to find the area. But, you know, in Calculus 2, I know you guys are going to do some fun stuff, rotating this shape around the x-axis and y-axis and everything. All right, let's go ahead and find the area of this blue shaded region. Now, who is higher? Who is greater? The purple line is y equals 5 minus x squared. This is the greater function. How do I know that's greater? It's above the x-axis. Now, if you want to do this algebraically, what you can do is just find the endpoints where they intersect, and then you can find the value that's in the middle of it, and just plug them in and see which one gives you the higher function value. You can do it that way. But for me, graphing is much easier, just so that I can see it. This one is y equals 5 minus 5x. And this is greater and, what's the, I'll just say smaller function. Because this is below it. So if I want to find what I'm integrating, I'm going to do the greater 5 minus x squared minus 5 minus 5x. Be careful with symbols here. 5 minus x squared minus 5 plus 5x, because you need to distribute that subtracting. You're subtracting a negative 5x. So if I combine like terms, my integrand is going to be negative x squared plus 5x. And then 5 minus 5, that cancels out. So this is the integrand. Now, what we need to find is the boundary points, because in order for us to evaluate definite integral, we need to know the lower bound and upper bound. And, you know, again, I kind of see that my lower bound is 0. I'll be more careful and say that's x equals 0. And I can't really see, but I think this is around x equals 5, looking at the x-axis here. But you've seen how I accidentally thought it was 80 up there, but when I actually did it algebraically, it came out to be 81. So don't believe the picture unless you click on these points. Let's find intersections, or I'll say find the bounds, by setting these two functions equal to each other, because these two graphs are bounded by each other, right? Left bound is their left intersection, and the right bound is their right intersection. So I'm going to find them by setting these equal to each other. Because when they are equal to each other, when the function values are equal to each other, that's when they intersect, right? And that's what I want to find. So this is a quadratic. Let me go ahead and move everybody to the right side. I'll have x squared minus 5x. And that's it. And if I solve this by factoring, I'll get x times x minus 5. So x equals 0. And what's the other one? 5. That matches what my graph gave me. So this is great. So we're ready. We're ready to set up a definite integral. Ready? So the definite integral will be from 0 to 5. These are our boundaries. And our integrand is negative x squared plus 5x. And the variable integration is x. All right, let's go ahead and evaluate this. First, find the antiderivative. Negative x to the third power divided by the new power of 3. Plus 5x squared divided by the new power of 2. And the bounds are 5 and 0. So what you're going to do is you're going to plug in 5 into all these x's. Negative 5 cubed over 3 plus 5 times 5 squared over 2. And then technically, what else do you need to do? You need to subtract the answer that you get from plugging in 0, right? Now, this is great because the part that I'm writing in blue, guys, this just turns out to be 0 again, right? So all I need to do is just find out what that red piece is. Okay, because that's going to be the area. Now go ahead and type this in your scientific calculator carefully. And let's see if you and I get the same answer. But hold on a second. By the way, are you expecting to get a positive or negative answer? Negative, right? Why? Why do we think that we're going to get a negative answer? Look, we got more area below the x-axis. Well, let's go ahead and type this in. Negative 5 cubed over 3. Plus 5 times 5 squared over 2. I think I typed everything in correctly and I hit enter. Oh, it came out to be a positive answer. So maybe I wasn't right. Maybe my eyes tricked me. Maybe there are more regions above the x-axis. Could it be the fact that I kind of messed with I kind of messed with the scale a little bit, right? Where the x-axis was going up by, 0, 1, 2, 3, 4, 5, 6. I made my y-axis go down by like 5. That's probably why. So I thought I had more region below the x-axis because that long piece looked long. But in fact, I got to kind of go back to the original zoom. So what they are saying is, hey, the area that we had above was actually greater. Okay. So maybe I really just shouldn't believe what my eyes tell me. She got to go with the actual number. But then the answer is 125 over 6. Did you also get that? 125 over 6. So if you want to convert that into a decimal, for a decimal answer is 20.83 repeating. This is approximately 20.83 repeating. Or you can also give them the mixed number. Because I think this section, I remember this section, they kind of wanted like different forms of answers. 20 and 5 over 6. This is also 20 and 5 over 6. But on your exam, when you do your number 8, either of them are fine. Decimal, fraction, mixed number are all fine. All right, so that was it. Let's do one more. And then after that one, I suggest you try that number 8 on your Google Doc, that review problem. And then that will get you ready for exam 3. And kind of sort of making this average value of a continuous function. Like, and this is not going to be covered on your exam 3, but I still have a couple problems on your homework. So come back and watch the average value of a continuous function video for me later. Let's do the very last one. Ooh, look at this. This is a quadratic and a quadratic. So we're going to go ahead and find the area bounded by 2 quadratic functions. So you know what I do. I'm going to go ahead and graph these 2 first. Graph. What I'm doing is I'm taking a picture of this graph equation so that I can, when I go to my Desmos app, I'll remember what they are, or I can see what they are. So the first function is y equals 2x squared minus 5x plus 5. It will be really impressive if you guys can include a picture on your exam. Then the second equation is y equals x squared plus 6x minus 5. Okay, so I wanted to kind of have a parabola, one opening upward, one opening downward, but they're both opening upward. Well, leading coefficients are both positive, but looks like they are meeting right here. First point is at 1, 2, but I gotta find the other point. It looks like, oh wow, they're going up kind of far. But with red one having a leading coefficient of 2, that one will eventually catch up, right? It's going up faster. But oh dear, how far will it take? How long will it take? Ooh, right here. I think they're touching somewhere over here. That's the point. At 10, 155. Also, it wasn't that far up. Maybe because my zoom was kind of extreme when I did the last problem. So I'm gonna go ahead and do, gonna mess with the zoom a little bit just because I want to have a good picture. I'll make my x-axis to go from -1 to 5 or 6. Oh, that looks good. And then I will make my y-axis to go from like -1 to, was it like 150? 150? Oh no, that was way too big. 130? Oh, no. Can't remember the number. Thought it was in the hundreds. Let me see. Let me try again. What was the number? The y value was approximately 155. Okay. But you know what? That's a good picture, don't you think? This is a good picture. I can see the endpoints are here. The intersections are at 1, 2 and 10, 155. Took a picture. Ready to have this picture on my note. Oh dear. I messed up. Oh no. I'll try again. See, this is why my lecture videos are so long, because I messed up with technology so bad. But I'm getting there. Thank you for your patience. All right, that's good. That is looking good. How do I save it? Done. Save to photos. I bought this used iPad on Facebook Marketplace, guys, when school closed. And I was like, I don't know how to write pretty with the computer mouse. So I think I'm using it every single day. So it's worth it. All right, so what we are finding is this area right here. Ooh. Okay. And I can see this blue graph. What was this one? I think this was y equals x squared plus 6x minus 5. And this red graph, which was y equals 2x squared minus 5x plus 5. Just double checking. Let me just double check. The red one is the one with 2. The red one is the one with 2. The red one is the one with 2. Yep. Because remember how the blue one was above, but then the red one kind of caught up eventually because it had a higher leading coefficient. So it was kind of going up a little bit faster. With the bigger A value, the graph is skinnier. So it kind of, you know, it catched up with the other guy. Catched up? It caught up? I think it's caught. So they eventually met, but I also was able to find their intersection point 10 and 1, but I'm gonna go ahead and find their intersection point by actually solving it algebraically, okay? Because remember what happened with my 80 and 81, so I don't want that to happen again. So, but first of all, let's find the integrand. Integrand. Because you know that we're subtracting, but then the order matters, right? Order matters. This one is greater because this is above. And this is smaller because this is below. So you're going to do greater minus the smaller. You will do x squared plus 6x minus 5 minus 2x squared minus 5x plus 5. X squared plus 6x minus 5. And be very careful with the subtracting one because you need to make sure to distribute the negative. Otherwise, we'll make a sign mistake. So the integrand is going to be negative x squared plus 11x minus 10. So keep that in your paper somewhere because now we are about to find the bounds. Find bounds. Okay? And the bounds are going to be the 2 points where they, intersect. Now, I want to see 1 and 10 when I solve it. Because that's what I kind of saw. But please go ahead and do include a piece, the work that you do algebraically, okay? The bounds are going to be when they intersect, when they are equal to each other. 2x squared minus 5x plus 5 equals x squared plus 6x minus 5. So let's set them equal to each other. Solving this by, I'm going to try to see if I can factor this. Moving everything to the left side. Minus x squared minus 6x plus 5. So I'm doing this to both sides. This turns into 1x squared minus 11x plus 10 equals 0. I think this is factorable. What times what gives you 10? 10 times 1. And if I make them both negative, they will add up to negative 11. That's how I got x equals 1 and x equals 10. And these are going to be our bounds. And that matched what they gave us on the picture, right? Awesome. So let's go ahead and find the area. Area equals integral from 1 to 10. What was our integrand? Negative x squared plus 11x minus 10 dx. All right, let's do our calculus. So this equals, find the antiderivative first. Negative x to the third power divided by 3 plus 11x squared divided by 2 minus 10x divided by 1, so I don't need to divide that by 1. But that's the antiderivative found real quick using the power rule. And using that intermediate notation that we learned, I'm going to go ahead and plug in 10 and 1 into it and just subtract them, okay? So I'm going to need a little more room. So let me go ahead and just minimize this work a little bit smaller. Make it smaller a little bit over there. Okay. Now, remember, so far, when we were plugging in the lower bounds were 0. So they canceled out nicely, but this is not going to cancel out. So I'm going to plug in 10 first. If I plug in 10, I'll get negative 10 cubed over 3 plus 11 times 10 squared over 2 minus 10 times 10. And then what do? You have to subtract this by the answer that you'll get when you plug in 1. Negative 1 cubed over 3 plus 11 times 1 squared over 2 minus 10 times 1. Do write that much work on your exam for me. And then after that, you can plug this into your calculator. But I do want you to show me that you understand, you know how to do the fundamental theorem of calculus to evaluate definite integrals. So don't go straight from this to answer. If you do that, I'll give you 0. Well, I give you 1 point for knowing how to type this in. But you're not going to get full credit if you just type the definite. And I need you to show me the fundamental theorem of calculus piece, okay? All right, let's type this in. I'm typing this on my calculator right now. Let me do the brown piece first, okay? 11 times 10 squared over 2 minus 10 times 10. The first one, the brown piece, came out to be 350 over 3. And then I'll do minus. I'll go and type in the second piece. For 3 plus 11 times 1, 2, minus 10 times 1. And when I typed the second piece in, I got negative 29 over 6. Okay? So let me go ahead and, we're going to end up adding them, huh? So add 350 over 3 plus 29 over 6. And that comes out to be 243 over 2. Or in decimal, if you want to convert that into a decimal, it is 121.5. Or in a mixed number, if you want to give me the mixed number too, or 121.5. Okay, so that is it. I think the last one was, I mean you have a calculator, so if you ever don't get so stuck on the fraction part, and I don't mind if you do the fraction in the calculator, but do show me the calculus work, the necessary steps, okay? Alrighty, so I'm gonna stop now because this will be enough for you to do number 8 on the exam. Please try that Google Doc number 8, the practice problem, and let me know if you want me to show you how to do that one, okay? Because I'm keeping your exam as either, the quadratic and quadratic was fun, don't you think? I really liked example 3. And the linear was good too, but I know I'm not going to give you a three lines. I'm just going to keep it as similar to 2 or 3, example 2 or 3. But I will be back shortly